destroying and eliminating microorganisms and other life forms that reside in and on the surfaces of objects. Autoclave sterilization is a physical method of sterilization that involves the use of moist heat, specifically in the form of saturated steam under pressure and at a temperature higher than 100 degrees Celsius. Out of the several methods available for sterilizing, pressurized steam sterilization has been found to be the most effective, reliable, economical, and least toxic, and therefore most widely employed technique for sterilizing medical and lab instruments. Steam sterilization is strongly microbicidal and sporicidal and has the ability to rapidly heat and penetrate the objects being sterilized, thus killing and destroying even the most resistant microorganisms in a matter of minutes to a few hours. There are four main parameters involved in effective steam sterilization: steam, pressure, temperature, and time. The materials to be sterilized are first exposed to saturated steam, which is under a specific pressure and heated to a specific temperature for a specific period of time. Moist heat in the form of saturated steam under pressure sterilizes an object by destroying microorganisms through an irreversible coagulation and denaturation of enzymes and structural proteins present in such microorganisms. And while we're discussing the role of saturated steam in sterilization processes, it is worth mentioning the difference between saturated steam and superheated steam and their differential roles in effecting or affecting sterilization. Simply put, saturated steam is the vapor form of water produced when water is heated to its boiling temperature under the prevailing pressure condition. In this state, the liquid and gaseous phases of water exist simultaneously. Applying a little more heat will cause more of the liquid water to turn into saturated steam, and removing a little heat will cause some of the steam to condense back to liquid water. But this slight change in heat supply will not result in a temperature increase or decrease beyond or below the boiling temperature. Saturated steam is also known as wet steam because it contains an abundance of water in its vapor form. However, if the vapor phase is isolated from the liquid phase, or the liquid phase has completely vaporized and then the vapor phase alone is heated beyond the boiling temperature of the liquid, then all traces of moisture from the vapor phase of water will be erased, forming dry steam or superheated steam. Proper sterilization of an object inside the autoclave is said to be achieved when the moisture-containing steam directly comes into contact with the object surface, gets condensed on the object surface, and in the process transfers its stored energy onto the object surface, thereby bringing about sterilization of the object. Even though the amount of energy stored in dry or superheated steam is higher than that which is stored in wet or saturated steam, the energy of superheated steam is virtually useless when it comes to effective sterilization, because it, being dry steam, does not contain the required moisture and therefore cannot condense on the object surface to transfer its energy for bringing about sterilization. For this very reason, saturated steam is a much more effective sterilizer than superheated steam. Water boils at 100 degrees Celsius under normal atmospheric air pressure. However, when the same water is exposed to a pressurized environment, according to the principle of gas laws, the boiling temperature of water also increases accordingly. At a pressure of 15 pounds per square inch, which is the usual pressure found inside an autoclave, water present in the autoclave is capable of achieving a boiling temperature of 121 degrees Celsius. At this temperature, the saturated steam produced by the boiling water effectively performs the role of sterilization in ways that were previously explained in this video. In this regard, it is also worth mentioning that it is not necessarily the high pressure achieved inside the autoclave, but rather the higher than normal boiling temperature achieved under such a pressurized environment, combined with the powerful penetrating and heat transferring ability of saturated steam, that kills organisms and sterilizes the objects inside an autoclave. The presence of dry air inside the autoclave hugely diminishes the sterilizing potential of saturated steam. It is therefore imperative that all residual air be removed from the autoclave chamber at the very beginning of the sterilization process. We'll elaborate on this when we come to the part on how to use an autoclave. A typical pressure cooker type autoclave steam sterilizer has the following main components: pressure gauge, which gives you the real-time pressure in pounds per square inch of the autoclave chamber; steam release or air exhaust valve. This is the outlet valve for complete removal of any enclosed air within the chamber at the very beginning of the sterilization process. Removal of residual air from the chamber results in a complete replacement of the air with steam or water vapor. This allows for a thorough and effective steam sterilization, as the name suggests. Pressure regulating valve or safety valve 1 with a green color code. This whistle-type pressure valve is designed to stabilize and maintain a sterilization pressure of 15 pounds per square inch within the autoclave chamber by letting out excess steam from the autoclave when it exceeds the 15 psi. So it's pretty much like an incubator thermostat that maintains a constant temperature within the incubator chamber. Double safety valve or safety valve 2 with a red color code. This whistle valve is kind of a fail-safe device that springs into action if the main safety valve 1 fails to let out steam at 15 psi and the pressure gauge reaches all the way up to 20 psi or so. At 18 to 20 psi, the double safety valve is supposed to whistle and blow out excess steam to re-stabilize internal pressure. Lid handle to aid in the opening and closing of the autoclave lid. Lid screws. About half a dozen or so tight-fitting, sturdy, nut and bolt type screws help secure the autoclave lid when in operation under high pressure. Vacuum release valve. This screw valve located behind the autoclave is opened at the end of the sterilization process to let out residual water and steam from the chamber. This creates a vacuum inside, which in turn extracts any residual steam and water from the contents being sterilized. Power supply port. Tripod stand for supporting the tray that houses the items to be sterilized. Immersion heater, which acts as the heat source for the sterilization process. Inner part of the vacuum release valve. Before we begin the sterilization, we must first process the items to be sterilized. I've brought together here an assemblage of some of the most common lab items that are routinely sterilized for culture experiments. In the case of screw cap reagent bottles containing liquid media, the cap must be loosened to avoid pressure buildup and potential explosion during sterilization. For containers without screw caps and containing liquid media such as this Erlenmeyer flask, the mouth of the container is plugged with cotton as seen here. Remember that the liquid media inside a container should never be more than 2/3 full, as it runs the chance of spillage and boiling over. Culture test tubes which may or may not contain liquid media are also plugged with cotton in the mouth. In the case of pipettes, their mouths are plugged with a small roll of cotton like you see here. Empty containers such as beakers and petri dishes along with the pipettes are wrapped in brown paper and securely tied with cotton threads. They may also be bagged in autoclavable plastic bags made of polypropylene or PP if available. Surgical and medical items such as gloves and forceps can also be wrapped in paper or autoclave bags. I've also given a link to a packaging method for gloves that will aid in effective sterilization. Do check out this link in the description below. Now paste small strips of autoclave tape on the surfaces and even within the deep reaches of the items to be sterilized. This chemical indicator is used to indicate if the sterilization temperature and/or pressure has been attained within the autoclave chamber and throughout the articles being autoclaved. However, autoclave tapes as standalone indicators cannot be used to test for the completion of sterilization. Biological sterilization indicators such as spore strips are usually used in combination with such chemical indicator tapes to check for both sterilization and attainment of sterilization conditions. That being said, using autoclave tapes alone largely suffice for most basic sterilization works. The autoclave tape, which has a uniform color throughout, to begin with, will show diagonal black stripes at the end of the autoclaving process, if sterilization conditions of temperature and pressure were achieved during the same. I'll be using autoclave tapes alone in this video. With the pasting of the indicator strips, processing of the items for sterilization is complete. Once the items have been processed for autoclaving, we place the items one by one into the sterilization bin or tray such that they fit snugly in the tray but without cramping, because we want the steam to effectively penetrate every nook and corner of the items to be sterilized. Now fill the autoclave chamber with clean water, preferably distilled water or RO water or rainwater. Using pure, clean water, preferably without any dissolved mineral content, is necessary because at high temperature and pressure, the impurities and dissolved minerals can easily react with the metal body of the autoclave and cause severe damages over time. Fill the autoclave to the point where the immersion heater coil is completely submerged in water, but the top of the tripod stand stays just above the water surface. Now place the loaded tray onto the tripod stand. Cover the autoclave with its lid. Secure the lid using the lid screws. A good practice for securing the lid tight is to first lift all the screws to their upright positions and then partially tighten each of the screws. Once all the screws have been partially tightened, make final checks, especially to see that the autoclave mouth is securely sealed all around by the rubber gasket of the lid. Now fully tighten the lid screws and the autoclave lid is now secured. Also make sure that the steam release and vacuum release valves are screwed tight. Also jiggle the two safety valves a bit to make sure they aren't stuck and can move freely. Also see that the pressure gauge reading is at 0. With all final checks made, the autoclave is now ready for operation. Switch on the autoclave heater. Wait and observe the pressure gauge reading. Once the pressure within the chamber reaches about 2 psi, open the steam release or air exhaust valve to let out all traces of air that is trapped within the autoclave. This allows the chamber to be filled exclusively with saturated steam, which is necessary for an effective steam sterilization. Once the pressure reading is back to 0, close the air exhaust valve tight to allow the pressure to gradually increase again. Depending on the size and capacity of the autoclave, it can take anywhere from 15 minutes to over an hour for the pressure within the autoclave to reach 15 psi with a temperature of 121 degrees Celsius. Begin the sterilization time countdown from when the pressure gauge reading first reaches the 15 psi mark. Once the gauge reading is at 15 to 17 psi, the pressure regulating valve or safety valve 1 comes into action, begins to whistle, and may or may not start to blow off excess steam. After several seconds of blowing off excess steam, the pressure reading goes back to just below 15 psi or so, and the cycle continues. Sterilization time periods usually adopted for some of the common items are shown here. For gloves, it's 10 to 15 minutes. For surgical items such as forceps, cotton, bandages, etc., sterilization time is usually 20 to 25 minutes. For glasswares, autoclavable plasticwares, and culture media, 15 to 20 minutes is a generally accepted sterilization time. At the end of the required time period, turn off the autoclave power supply. Now place a heat-resistant container such as steel cup beneath the vacuum release valve. Carefully loosen the screw knob to open the valve. A gush of water and saturated steam is released, which will collect in the steel container below. Once the steam and water ceases to freely come out of the valve, close the screw knob of the valve tight. Removal of steam and water from the autoclave chamber creates a vacuum environment within the autoclave, which will in turn facilitate complete extraction of residual steam from the contents inside the autoclave. After closing the vacuum valve, allow the autoclave to cool down for about an hour or so. Once it has sufficiently cooled down, open the steam release or air exhaust valve to destroy the vacuum inside the chamber. Now loosen the lid screws one by one and carefully open the autoclave lid. Remove the sterilized contents from the autoclave and place them in a clean and dry area. Check the autoclave tape strips for black diagonal lines. If they appear on the strips, it means that the required conditions for sterilization were attained during the procedure. Unwrap the articles only just before use, preferably within the confines of a sterile LAF or inoculation chamber. So this is all about the fundamental principles, components, and working of a autoclave steam sterilizer. Thanks for watching.